Hello, and welcome to our online course for SPM analysis of EEG and MEG. My name is Vladimir Litvak. I'm one of the members of the SPM team. And in the next 15 minutes or so, I will give you an overview of the history of SPM, the course program, and different resources that you can access before, during, or after the course to get more information about different SPM analysis. So SPM originated in the late 80s, early 90s when Carl Freestone and colleagues developed tools in MATLAB to analyze initially PET images and later extended this framework to MRI, fMRI, and EEG and MEG. So this is one of the first SPM analysis of PET from 1989, where they compared subjects viewing colored images with those viewing grayscale images and found visual area sensitive to color. So at that time, that was sufficient to get a Nature paper, but I think nowadays you would need to work a bit harder to get to the same level. So this is a typical analysis pipeline in SPM. So in this case, this is the pipeline for structural or functional MRI data, and that involved realignment of images and spatial normalization, followed by smoothing and application of a general linear model, which is something that we will learn about later today. So general linear models basically is a very flexible statistical framework which generalizes ideas like t-test, ANOVA, and regression in the same tool. And this analysis gives you some kind of activation patterns in the brain. And the next step is to threshold those patterns to determine which ones are statistically significant. And this is done by application of mathematical framework called random field theory. And eventually you end up with blobs on the brain in this case that you must be very familiar with. Over the years, there have also been various other applications of SPM. So the important point is that this framework can be applied to any continuous processes in 1, 2, 3, or more dimensions. Although in SPM we only implemented it up to 3, and it has been applied to things like bond density or levels of pressure during stepping. So anything that is basically contiguous along a spatial or frequency or time dimension can be studied using SPM. So in particular, EEG and MEG also fall under a special case of this framework, and that's what you will learn during the day today. So the steps involving that in SPM, they start with pre-processing, which is quite similar to what is implemented in other toolboxes, things like filtering, epoching, or re-referencing. And that is followed by application of general linear model, which can be applied in several different ways, either to sculpt data with sculpt and time or time frequency, or source reconstructed data. And then this is followed by statistical inference based on random field theory, which gives you your significant activations. So this whole framework will be the topic of the first day of the course. In the second day, you will get more into Bayesian framework and modeling. And the general idea is that if you can have a generative model, so basically something that tells you how your data is generated by some mechanism in the brain, the Bayesian framework in SPM gives you tools to invert this model and go from the data to model parameters. So in the case of source reconstruction, the parameters of interest are current source densities in the brain. And this model can be inverted based on SCALP, EEG, and MEG data. And you will learn more about that tomorrow. Another topic of the second day of the course is optical pump magnetometer, so wearable magnetoencephalography. So this is a topic that is under active development and research in our department right now, and you will learn about the basics of OPM and of some OPM-specific preprocessing and denoising methods. That will also be on day 2. And day 3 will be about modeling framework, which is also very important in SPM, and this is dynamic causal modeling. So that this framework allows you to invert more complicated models that involve not just source locations, but also neurophysiological mechanism of how EEG and MEG signals are generated by neuronal populations. So we now have two common variants of DCM that people use. One is DCM for event-related potentials, and the other is DCM for cross-spectral density. Historically, there have also been simpler models for induced responses and phase coupling that you can still find documentation about, but we will not include them in the course right now. So what is actually SPM, where you can find it? So SPM is a free and open source academic MATLAB toolbox. So right now, the main place to go to get the latest version is on GitHub. The installation for SPM is very simple. We just download the SPM folder from GitHub and add the root folder, which is important, just a root folder without subfolders to the MATLAB path. So the supported MATLAB versions are from 2020A to 2024B, but SPM might also run on earlier versions. We just stopped testing on them. SPM can also run on different platforms, Linux, Windows, and Mac. For people who don't have access to MATLAB, there's also a standalone version and a new framework also to serve Python users is SPM Python interface. So this is something that requires a runtime MATLAB library for Python, and it supports different things like conversion between SPM and MNE Python data structure. So you can write a pipeline which for some steps uses SPM code. And also it allows easy transition for SPM users to MATLAB to Python because they can specify the analysis via batches or model specifications in a way that is very similar to MATLAB syntax. So we'll have a special session during our practical day where we'll see a demonstration of this framework. So the main source of information about SPM right now is SPM website, which is part of our departmental website. And you can find the information about courses, about different references for SPM, and links to other SPM resources. For developers and users who want to stay up to date, as I said, the main source of information is the SPM GitHub page, where you can get access to the latest development version, report bugs, and also contribute to the software and documentation. There are several other sources of documentation about SPM. So there's a PDF manual that is included in SPM distribution. So this is slightly outdated way of documentation that we are trying to move away from. But you can still, like if you prefer reading PDF documents, you can still find most of the information there. There's a paper that was published in 2011, and which deals with analysis of EEG and MEG in SPM8. So although some interface details have changed since then, but the basic ideas of analysis are still not outdated, so you can read this paper as well. And a more recent paper about multimodal integration of EEG, MEG, and fMRI data that gives you a specific walkthrough through an example of group analysis in SPM, and we will use parts of this example also here during the course. So some other sources of information that might be useful is this SPM book, which is published, I think, in 2006. but for deep dive into the concepts and mathematical ideas behind SPM, it is still useful because those ideas have not changed much. Another source of information would be just SPM code, which is quite well structured and well documented. So if you really want to find documentation about specific functions, about low level interfaces in SPM, I think you can look also in the code itself. So we are now in the process of moving to a new documentation website. So the course page is actually part of this website. And so most of the documentation that was previously in the PDF manual that was moved over to this website. And there are also some new chapters, such as chapters about OPMs, which are now only available in this framework. So this is the place where we recommend you go to for tutorials and for reference documentation for different SPM analysis. Also, on the website, you will find the tutorials page, and that gives you access to different data sets that you can work on to learn analysis of EEG and MEG, SPM, OPMs, as well as other modalities. And this is something that you can work on during the practical day. Just choose whatever is most relevant to you, and you will get help from SPM experts and the course faculty. On the main website, you can also find the toolbox page. So over the years, different SPM power users and developers contributed toolboxes to SPM, which deal with different extending different SPM functionalities. So most of them are for MRI and fMRI, but there are also several relevant to EEG and MEG, such as, for instance, toolbox for sleep analysis and other toolboxes. The main source for getting information about different problems that you might run into and also asking questions is SPM mailing list. So we have a vibrant international community of people posting to the list, asking and answering, and you can also use it to post things like jobs. And I think this is the best resource so that other people can also learn from your question. So I hope you enjoy the course, and maybe in the future years you'll become part of this community and will also contribute to SPM as developers and power users. Thank you, and enjoy the rest of the day.